Good morning everyone. I am Mrs. P.HAMEETHA BEGUM, Assistant Professor of Mathematics, A.D.M. College for Women, Autonomous, NAGAPATTINAM. Today I am going to discuss about the topic Vector Calculus and Fourier Series. It is one of the core subjects of the second BSc Mathematics students. Before going to the topic, let us see what is a scalar. A scalar is a quantity which has magnitude alone and no direction. An example is length, mass, time, etc. Next, let us see what is a vector. A vector is a quantity which has both magnitude and direction. And the examples are displacement, velocity, acceleration, force, etc. Now let us see the vector differentiation. This is the first unit for the students. So generally, if f of t is one valued function of t, then the derivative is given by dou f by dou t, which is equal to limit delta t tends to 0, f of t plus delta t minus f of t divided by del t. And if the Cartesian components of f of t are functions of t, that is x of t, y of t and z of t, then we can write f as I into x of t plus j into y of t and plus k into z of t, where I, j, k denote the unit vector along the coordinate axis. Therefore, dou f by dou t is given by I vector into dou x by dou t plus j vector into dou y by dou t plus k vector into dou z by dou t. Now let us see the vector differential operator. It is written as del, which is equal to I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Already we seen I, j, k are the unit vectors along the axis ox, oy, oz. And this operator is called the Hamiltonian operator. And this operator is not a vector, but it combines both differential and vectorial analogous properties to those of ordinary vectors. And the note is given as del is a way to find the derivative of a vector. If a vector is given, we can use del and find the derivative. Next, let us see the gradient of a vector. Given phi of x comma y comma z be any scalar function and it is differentiable at each point x comma y comma z. Then the scalar point function del phi is given by I dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. This is the formula for finding the gradient of a vector, that is del phi. Next, the formula for unit normal vector, that is the vector normal to the given space. That is denoted by n cap, and the formula is del phi divided by modulus of del phi. The one more formula is there, that is the directional derivative. The directional derivative of a scalar point function phi in a given direction A vector is the rate of change of phi in that direction. That is directional derivative dd is equal to, shortly written as d dot d, which is equal to del phi dot A vector divided by modulus of A vector. Now let us see some solved problems using the previous formula. The first one is if phi is equal to x square plus y square plus z square minus 8, that is the given space equation, then find grade phi at 2, 0, 2. So we have to find the gradient of phi and at the point 2, 0, 2 the value of del phi. So given, first you can write the given details, that is phi equal to x square plus y square plus z square minus 8. Then we have to find del phi. Already we know the formula, that is I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. Then we have to substitute the phi value in each and every term. That is the coefficient of I vector, that is the dou of the given phi divided by dou x plus j into dou of the given phi divided by dou y and k vector into dou of phi divided by dou z. So the first term we have to differentiate with respect to x, and the first term only we are having x value. Therefore, differentiating it, we get 2x I vector. And similarly, in the second and the third terms, we get the values 2y j vector and 2z k vector. Therefore, del phi we have found. And one more thing we have to find is 2, 0, 2. At that point, what is the value of grade phi? Now substitute the value of 2, 0 and 2 instead of x, y, z. So we get the answer 4 times I plus 4 times k vector, and the coefficient of j is 0. Therefore, the answer is 4 into I plus k vectors. The second problem. So find the unit vector normal to the surface x square y plus 2x z square minus 2 equal to 0 at the point 1, 0, 2. So given data is the surface equation phi, that is x square y plus 2x z square minus 2 equal to 0. We have to find unit vector normal to the surface, and the formula given by del phi by modulus of del phi. So first find grade phi, that is del phi, and then modulus of del phi, and then n cap. So first del phi is equal to I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So in the previous problem, as in the previous problem, we have to differentiate the first term with respect to x, and the second term with respect to y, and the third term with respect to z. And in the first term, in the two terms we have x values, so differentiating that we get 2 times xy plus 2 times z square, that is the coefficient of I vector is 2xy plus 2z square, and in the coefficient of j vector is x square alone, as one term only having the value x square y, and the other terms y is missing. Therefore, that differentiating that terms we get 0, and the coefficient of j vector is x square alone. And in the third term, we have only one term contains z value. Therefore, differentiating we get 4 times x z into k vector. And again we have to find the del phi at the point 1, 0, 2. So substitute 1 instead of x, 0 instead of y, and 2 instead of z. So substituting we get the answer 8 I vector plus j vector plus 8 times k vector. So we have found del phi. And one more thing we have to find, modulus of del phi. So modulus, how will you find? Square the coefficients of I, j, k and add it and find the square root value of that values. So squaring we get 8 square plus 1 square plus 8 square, and under the square root, therefore the answer is root of 129. Now we can find the n cap, that is the unit vector normal to the surface, that is n cap is equal to del phi divided by modulus of del phi, that is equal to 8i plus j plus 8k vector divided by root of 129. So this is the answer. Next one, find the directional derivative of phi of x, y, z, that is equal to x y square plus y z cube at the point 2, minus 1, 1 in the direction of the vector I vector plus 2j vector plus 2k vector. So in this problem we have to find the directional derivative of the function phi at the point 2, minus 1, 1 in the direction I plus 2j plus 2k. So first let us write the given data. So given write the surface equation phi xy square plus yz cube, and the vector is given as I plus 2j plus 2k. So take it as a vector. Next one, the formula for the directional derivative is del phi dot a vector divided by modulus of a vector. So first we have to find del phi. So as in the previous problems, we can find the del phi. So differentiating the first term with respect to x, second term with respect to y, and the third term with respect to z. So we get the answer y square I vector plus 2xy plus z cube j vector plus 3y z square k vector. And we have to substitute the value, the point value, 2, minus 1, 1. So instead of x replace 2 and y is replaced by minus 1 and z is replaced by 1. So the del phi answer is I vector minus 3j vector minus 3k vector. now let us find A vector divided by modulus of A vector. The answer is I vector plus 2j plus 2k vector divided by the modulus of A. We have to square the values of the coefficients I, j, k in the value given A vector. Therefore, square root of 1 plus 4 plus 4, we get root 9 and the answer is 3. Therefore, A vector divided by modulus of A vector is I vector plus 2j plus 2k vector divided by 3. Now, the directional derivative is we have to dot product both del phi and A vector by modulus of A vector. So, dot producting we get the answer minus 11 divided by 3. So, in numerator we have two vectors. So, dot product I dot I becomes 1, j dot j becomes 1 and k dot k becomes 1, and multiplying and adding all the numerators we get minus 11 and the denominator is 3. Hence, the directional derivative is minus 11 by 3. The next problem, next two problems again we are going to find the directional derivative, but the vector given is of a different type. That is, find the directional derivative of 2x z square minus 3xy minus 4x equal to 7 at the point 1 comma minus 1 comma 2 along x axis. In the previous problem, the vector A is specifically given, but here the vector is given as along x axis. Only the in x direction only the vector is moving. Therefore, let us write the given data phi as 2xz square minus 3xy minus 4x minus 7, and the point given is 1 minus 1 and 2. But along the x axis means other axis, the movement on the other axis are 0. Therefore, we can find only phi, the differentiation of phi with respect to x alone. So, dou phi by dou x, we get the answer 2 z square minus 3 times y minus 4, and at the point 1 comma minus 1 comma 2 we get the value 7. Therefore, the directional derivative of the given phi at the point 1 minus 1 2 along x axis is 7. The next problem, find the maximum directional derivative of phi which is equal to x y z square at 1 comma 0 comma 3. But here the direction is not given specifically, only the surface equation and the point is given. So, they are asking maximum directional derivative. So, let us find del phi at the point 1 comma 0 comma 3, and the maximum value, maximum coefficient of the vector is the maximum directional derivative. Okay. So, given phi of x y z is equal to x into y into z square. Find the del phi as usual, differentiating the first term with respect to x, second term with respect to y, and the third term with respect to z. Then we get the answer y z square I vector plus x z square j vector plus x y 2 times x y z k vector, and substituting the values 1, 0, 3 instead of x comma y comma z, we get the first term 0 I vector, the second term 9 j vector, and the third term is 0 k vector. In this answer, we are having the maximum value for the vector j, that is in the direction y. Therefore, the maximum directional derivative, the other values are 0, therefore, the maximum directional derivative is 9 j vector. And the next problem, if del phi is equal to 2x y z cube I vector plus x square z cube j vector plus 3x square y z square k vector, find phi of x comma y comma z given that phi of 1 comma minus 2 comma minus 2 is equal to 4. So, previously we have formulae and find out the values as grade phi, a normal unit normal vector, directional derivative. But here they have given the gradient of phi and ask us to find the phi, the simply scalar function. Okay. So, let us see how to find. So, given del phi is equal to 2xyz cube I vector plus x square z cube k j vector plus 3 times x square y z square k vector. Now, the value of del phi is, the formula for del phi we know that is I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. let us now substitute the formula for del phi in the left hand side and the right hand side the given value in the problem. Okay. So now equate the like terms, that is the coefficient of I vector from the left hand side and the coefficient of I vector from the right hand side. Similarly, for the vector j and k, we have dou phi by dou x is equal to 2xy z cube, dou phi by dou y is equal to x square z cube, and dou phi by dou z is equal to 3 times x square y z square. Now, first let us take the first equation, differential equation, dou phi by dou x, which is equal to 2xy z cube. Now, bring the denominator dou x to the right hand side. Then we have dou phi is equal to 2xy z cube dou x. Now, integrating the above equation, this equation we get integral dou phi equal to integral 2xy z cube dou x. Here we have to put the ordinary differential equation d phi. Wrongly I have put dou phi, so excuse me. So which implies integrating we get left hand side phi 1. Why we are indicating phi 1 means we have to integrate further with respect to y and z. Therefore, that values will be named as phi 2 and phi 3. So we are indicating here as phi 1 left hand side, which is equal to right hand side we have to integrate with respect to x, but we are having all the variables x, y, z. So here treat y, z as the constants as 2 and integrate with respect to x alone. So we get the answer 2 times x square by 2 into y z cube plus constant c1. As it is the general integration, we have to put constant c1. So similarly, we can differentiate the differential equations. Second one and third one, that is dou phi by dou y and dou phi by dou z, we get phi 2 and phi 3. So phi 2 integrate with respect to y alone, the right hand side, and in the third equation integrate with respect to z alone, the right hand side. So we get the answer as phi 2 and phi 3. Now we have to consolidate phi from these phi 1, phi 2, phi 3. So how will you consolidate? You have to select the non-repeated values for the right hand side. So the first answer also we have x square y z cube. In the phi 2 also we are having the same term x square y z cube, and similarly as in phi 3. So we have to collect the non-repeated terms from phi 1, phi 2 and phi 3. So the only term is repeated, that is x square z cube and y. Therefore, phi is equal to x square z cube y plus c. So we have found phi from del phi. Okay. Now we have to substitute the point 1, minus 2 and minus 2 in the surface equation phi. So replacing x by 1, y by minus 2 and z by minus 2, we get the answer 1 square minus 2 whole cube into minus 2. So answer is minus 16 plus some constant c. Okay. Found phi of 1 comma minus 2 comma minus 2 as minus 16 plus c. But in the given problem, they have given phi of 1 comma minus 2 comma minus 2 is equal to 4. Therefore, we get the value c as 20. Okay. So substituting this c value in phi, we get phi is equal to x square z cube y plus 20. Therefore, we can find phi if gradient of phi also given. Okay. So in the next problem, so the temperature, the next problem, the temperature at any point x comma y comma z at time t is phi of x comma y comma z comma t is equal to 2x square y plus y z square t minus cos xt. Find the rate of change of temperature with respect to time encountered by the particle passing through the point 3 comma minus 2 comma 1. V vector is equal to 2i minus j plus k vector at time t equal to 0. So here the temperature is given as the function of x, y, z and t, that is 2x square y plus y z square t minus cos xt, cos of xt. Now we have to find the rate of change of temperature with respect to time. and the temperature is given as phi, and we have to find the rate of change of temperature with respect to time by the particle passing through the point. One point is given and one vector v is given at time t equal to 0. So the given value, first write the given value phi and the point, the vector, and time t equal to 0. So we have to find the rate of change of temperature, that is given by d phi by dt, because they asked us to find the rate of change of temperature with respect to time, that is d phi by dt. How to find d phi by dt? But phi is depending on x, y, z and t. Therefore, we have to write the equation d phi by dt is equal to dou phi by dou x, as phi depends on more than one variable. We have to use the partial differential. Therefore, dou phi by dou x into dx by dt. Why we are writing dx? Ordinary differentiation means x depends on t alone, but phi depends on x, y, z and t. Therefore, producting the partial derivative and the ordinary derivative. We get the first term dou phi by dou x into dx by dt plus dou phi by dou y into dy by dt plus dou phi by dou z into dz by dt plus again phi depends on t also. Therefore, we have dou phi by dou t. Okay. Next, we have to this equation. Taking the right hand side has totally 4 terms. Consider the first 3 terms, and the first 3 terms, addition of first 3 terms can be written as the dot product of I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z dot I vector dx by dt plus j vector dy by dt plus k vector dz by dt. If you refer the dot product means we can get the previous step. So plus the last term dou phi by dou t, and in the dot product the first term can be written as del phi. It's nothing but del phi, I dou phi by dou x plus j dou phi by dou y plus k vector dou phi by dou z is nothing, the gradient of phi. And dot product, what is the value? I dx by dt plus j dy by dt plus k dz by dt. It's nothing but the differentiation of r vector, position vector r with respect to t. We know that r vector is xi plus yj plus zk, and differentiating r with respect to t, we get the above term. Okay, so del phi dot dr vector divided by dt plus dou phi by dt, dou t, which is equal to, now del phi dot, in place of dr vector by dt, we can replace as v, that is velocity v is equal to differentiation of r with respect to t. Therefore, we can write the equation as del phi dot v vector plus dou phi by dou t. So consider this equation as 1. So after finding all the values, that is del phi, dou phi by dou t, we can find the value of the equation 1. Now find the grade phi. Already given our surface equation as, take the surface equation as phi. So we have to find the del phi from that. As usual, differentiate the first term with respect to x, and the second term with respect to y, and the third one with respect to z. So we get the answer 4 times xy plus t into sin xt, that is cos xt. Differentiating cos of xt, we have sin of xt into t, and the minus becomes positive. Okay, so 4xy plus t times sin of xt into I vector, and the second term, that is the coefficient of j vector, is 2x square plus z square t plus 2yz t k vector. Now at t equal to 0, we have to find del phi at the point, that is 3, minus 2, 1. They have given this point at time t equal to 0, the vector is at this point. Therefore, del phi is equal to, substituting 3 instead of x and minus 2 instead of y, 1 instead of z, we get the answer minus 24 I vector plus 18 j vector. And also we have to find dou phi by dou t, then only we can find the answer for the equation 1. What is dou phi by dou t? We have already phi is given, and differentiate that phi with respect to t alone. we get the answer minus 2, substituting the value of 3 minus 2 comma 1. Therefore, we have found del phi and dou phi by dou t. Already V vector is given. Then we can find equation 1. Therefore, d phi by dt, equation 1 becomes d phi by dt is equal to del phi, that is minus 24i plus 18j dot V vector 2i minus j plus k vector, and dou phi by dou t is minus 2. Therefore, plus value becomes here minus 2, and the final answer is minus 68. We can check it. Now, we have seen nearly 7 problems, I think. We can practice all these problems as in the same manner using the formula given above. Next, let us see the divergence part. So, divergence and curl. What do you mean by divergence? If an f vector is given and defined, and it is differentiable at each point x comma y comma z in a certain space, we can find the divergence of f vector, that is written as div f or del dot f vector. So, del dot f means, del we know that the differential operator, that is a Hamiltonian operator, I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z dot f vector. So, which is equal to, we have to replace f vector by f1i plus f2j plus f3k vector. So, dot producting we get I dot I becomes 1, j dot j becomes 1, and k dot k becomes 1. So, we get the answer dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So, this is the divergence of a given vector. And next, let us see the curl of a given vector. If a vector f is given and we have to find the curl, means it is denoted by curl f vector or del cross f vector. For divergence, it is dot product, and curl, it is cross product. So, del cross f, which is equal to, replace del by the formula given and cross f vector. So, how to find the cross vector? We have to find the determinant 3 cross 3, as 3 directions are given in f vector. We have to find the determinant of a 3 cross 3 matrix, with the first row as I, j, k, and second row as dou by dou x, dou by dou y, dou by dou z, and the third row as the coefficients of f vector, that is f1, f2, f3. And as usual, we know expansion of a determinant. So, keeping I vector first row and expanding first row, we get I vector into dou f3 by dou y minus dou f2 by dou z minus j vector into dou f3 by dou x minus dou f1 by dou z plus k vector dou f2 by dou x minus dou f1 by dou y. And in the second term, that is the coefficient of j vector, the minus is multiplied inside, and the term becomes plus j vector into dou f1 by dou z minus dou f3 by dou x. It will be very helpful in calculating the cross values in many problems, so that we have changed that. So, curl vector means del cross f vector, and divergence of f means del dot f vector. Next, let us see what is solenoidal and irrotational. Solenoidal and irrotational means, if the divergence of a given vector f is 0, then the vector is given as the solenoidal, and if the curl of that f vector is 0, then f is said to be irrotational. Okay, and divergence of f is a scalar point function, and the curl of f vector is a vector point function. In the next class, we will see the solved problems under this topic. Thank you.